I'd work through this one with you, again, kind of show you, what to do, give you a good example. You can kind of follow along with me. And then the next one, I'm going to have basically give you guys a chance to see if you can kind of put it together a little bit. You might do well in some parts, might do poorly in other parts. We'll try to sum it all the way back up. The good news is this, as I've talked with a few folks over the last 24 hours about this is going well, or I'm struggling with this, or whatever. For most folks, the struggle is factoring. Right? So like once you get the factoring complete, then the thing that you need to do becomes relatively clear. And so the good news is, and by the way, double good news, almost everyone completed the intro video. I think we were just like one or two folks shy of completing the intro video, so you're doing better. If you did, which most of you did complete the intro video, you saw that most of that, what we're going to talk about today and the next couple days, is still factoring. So if you are weak on factoring, we are going to keep at it and keep at it and keep at it. You're going to get lots of chances to practice and ask questions and hopefully improve as we go. Okay? So let's do this one here together. Number 4. If you remember yesterday, I gave you one of those teacher-y kind of things where I give you some steps. And so yesterday, and you all said, or the majority of you said, yeah, I like it when I get these concrete step 1, step 2 type things. And so I'm going to tell you right now, if you're tasked with simplifying a rational expression like this, the first thing you got to do is you got to ask yourself, could the top and or the bottom be factored? We want to try to factor the bottom or the top. It's always going to be our first step. Okay? So I'm going to take a look at the top. And, if you want to do this work off to the side, you are totally welcome to do this. Maybe we just copy this over here, 4x squared plus 32x. And maybe we ask ourselves, how do I factor this? Is it factorable? And the first thing you should always do is decide if there's a GCF. So do you guys see a common factor that we could pull out?
4x.
4, and yeah, there's a common x, right? So Ashlyn, if I do pull the 4x out, what would the leftover expression be back in the parentheses?
X is 8.
Thank you, Ashlyn. You've changed so much. Say it again. X plus, she had her hand up, so I called her. So x plus 8 would be the leftovers, correct? Take a minute and think about that. Does that make sense? Any questions? So at that stage, I'd say that we've factored the numerator. So I'm going to put it back into the fraction here. So it's going to be 4x parentheses x plus 8 over. Now let's take a look at the denominator. Oops, I missed. There we go. X plus 8. 8 plus x. Can we factor that? Could we factor out a GCF maybe?
You can eliminate the x's.
Hold on. I didn't say anything about eliminating anything. This is really critical, Garrett. I want you to listen really carefully. The first thing you do before you do anything else, before you blow your nose or get a drink, is you factor. You don't worry about anything about getting rid of anything. You simply factor. So when you look at that x plus 8, 8 plus x, is there a GCF? There's no common factor at all. It's not even a trinomial. Is it that difference of squares things that sometimes is hard to see?
No.
It's not a difference of squares either. So what's the conclusion on 8 plus x? Say again? Just leave it as it's prime, right? Leave it as is. Yeah, there's no factoring that could be done with that. The only thing you might want to do, I don't know, it doesn't really matter if you do this or not, would be to change the order around. That's not really doing anything of substance other than maybe visually might be a little bit nicer. Because if you do flip the order around, can you now see how the entire denominator actually exactly matches one of the factors in the numerator? So what I can then do is I can cancel this entire factor with that entire factor. Okay? So Garrett, I want to be super clear. It sounded like maybe you were wanting to cancel this with this.
Yeah.
Cannot do it because there's nothing really inherently wrong with this, but you cannot cancel part of a sum. You can either cancel the whole thing or none of it. So that would not be a good strategy. What you could do, though, is you can cancel this with the whole thing, the whole factor down there in the denominator. Of course, that would leave you, wouldn't that leave you with an empty denominator?
Yeah.
So whenever you have a numerator or a denominator that's empty, what do you put? A 1, yeah. So you could put 4x over 1, but in reality, because the denominator is a 1, if you just wanted to put 4x, that's fine too. It's fine too. Okay, so what is the first step? Always. Factoring. Doesn't mean that it's an easy step. That's always the first step. And would you guys agree that if you factor first, then all the canceling becomes a little bit more clear? Like I could cancel this whole factor with that whole factor, so on. Okay. Good deal. Let me give you guys a chance to try to put all of that section together, and that's question number 5. So flip over to there. This will be your opportunity to kind of work with a partner, maybe work by yourself a little bit if you want, and see if you can handle those questions there. It's kind of takes up the whole page. You got your notes in front of you. Alec, I'll just leave it up there like that for you, so you can kind of see it, but then I'll just kind of zoom back out when it's time to work on it, okay? So take a minute and check that out. See what you can do with ABC. Summative opportunity to kind of see, do you get all of 7.1, right? Do you kind of get all of it? Can you put it together? So in part A, it says, which values of x cause the expression to be undefined? So let's remember, is it the numerator or the denominator that might cause a fraction to be undefined? It's the denominator, actually, right? So you cannot have a 0 in the denominator because you can't divide by 0. And so if I'm looking for the values of x that cause the expression to be undefined, I'm always going to take the denominator and set it equal to 0. So there's that. And then I've got to solve this. So x squared minus 3x equals 0. Well, my first step is always going to be to try to look for a GCF. Do you guys see a GCF between those two terms? In x? Yeah. So if you do factor out an x, the leftovers would be x minus 3. And now we can use that zero factor property to solve. So it would be x equals 0, x minus 3 equals 0. So your two excluded values would be x equals 0 or x is equal to positive 3. Okay, so take a minute, look at what you wrote. Look at what I wrote. Do you have questions? Now's your chance. Please do ask. Ask yourself, do you get these big takeaways? A fraction will be undefined when the denominator is 0. So that's why I set the denominator equal to 0. And then I used factoring to break it down into factors. Use the zero factor property to then solve. Can I ask you guys just a real brief question here? Just a very, it might seem, well, it's very applicable, but it might seem a little bit off the beaten path. Can anybody else identify with this? Like when you're in a math class, isn't it really easy to sort of like not really read the words on the page and jump straight to the math-looking stuff? You know what I'm talking about? Isn't it super easy to just like, basically in your head, are you watching? Isn't it really easy in your head to basically just do this? And all of this. And all you really see is that. You know what I'm talking about? You put blinders on when there's words and stuff. But oh boy, I'll tell you what. When we see stuff like this, it's high alert because there's X's and numbers and minus signs and stuff, right? We want to be really, listen, please be super careful to avoid that. I would ask you to engage with the words. This is a really challenging, for those that tend to do that, this is a really challenging topic, challenging question, because didn't all three questions have something to do with the exact same math thing? Yet all three questions were different, weren't they? And so if you don't actually read the words, you're just going to jump off and just start doing something. The something that you did might not be the something that you were asked to do. So the words carry a ton of weight, a ton of conceptual weight. Okay? So if you're looking up there and you're just like, golly, Mr. Anderson, I see that you did some math, but I have no clue why you did what you did. Do you know why? Because you're not focusing on the content and meaning of the words. It has nothing to do with the numbers. If you're asking why, now if there's detailed stuff with the numbers, I get it. But if you're saying, well, how did you notice that the denominator equal to 0? Doesn't that have everything to do with the words? How did you know that I wasn't supposed to do something with the numerator? That has everything to do with the words. So take your time, carefully read the words. Does that make sense? Okay, so then you're going to find with B, we do something else entirely different, right? So B, if you read the words carefully, the words say simplify that same expression, right, that showed up again, simplify completely. Can anybody maybe paraphrase what simplify completely means? One word answer. We did it yesterday. It was up there on the board earlier. Play a little Wheel of Fortune. Starts with the letter R. Oh, I just think I heard Avery say it. It's reduce.
Reduce.
Reduce to lowest terms, right, would be kind of the phrase that you saw back in fifth grade or whatever. This is really reducing to lowest terms. And this is kind of like what we did just a second ago in our little warm-up. And so with this, if you're going to be reducing to lowest terms or simplifying completely, the very first thing you've got to do every time is factor. There you go. Remember that first step? If it says simplify completely, the very first thing you always do is you factor. Did you say it and I didn't hear you? Okay. So the good news is, wouldn't you guys say that based on our work in the first question, didn't we already factor the denominator? So I don't need to reinvent the wheel there. I'm just going to say, you know what? I know that the factoring on that is x times x minus 3, but I didn't touch the numerator in A, and so I'm going to need to look at the factoring of the numerator. So in the numerator is this. Does this have a GCF I could pull out? No GCF. That's right. But it is a trinomial, and so what I could do then is maybe go off to the side and use the split the B magic X method to help me get this factored. So we come over here. What's my AC? -6, and the B is -1. So I need to decide which two numbers work in the X. What did you guys think?
-3 and +2.
Yep, -3 with +2. That works just fine. I keep on with the factoring process. I'm going to split the B up like this. And then I always group the first two, group the second two, and add. What's the common factor in the first grouping? That's right. And the leftovers are x minus 3. And what should I factor out of the second grouping?
2.
This time a +2, right? Now, sometimes we factor negatives out of there, but this time a +2 will get it done for us. So then can you see how we would factor out the x minus 3s? So then I'll just write my factoring over here. It would end up being x minus 3 times x plus 2. Okay. So remember, the goal is to simplify completely. I'm not finding numbers that make this undefined. I'm not evaluating anything here. I'm simply trying to reduce this to lowest terms. I factored the top. I factored the bottom. And when you do this, don't the things that cancel become a little bit more clear? Maybe a lot more clear? What do you see that cancels? The x minus 3s, yes. So this entire x minus 3 cancels with that entire x minus 3, leaving me with x plus 2 in the top and x down there in the denominator. Did you guys get that for an answer? X plus 2 over x. That is the final answer. Isn't it really tempting to go back in and say, oh, this and this? It's tempting. It's wrong, though. Remember, you cannot cancel part of an addition or subtraction problem. You can only cancel whole factors. So what I just did there would have been bad. Okay. Do you see how the words matter? In A, I set the denominator equal to 0 because I was looking for numbers that made the fraction undefined. In B, I had to factor everything because I was trying to simplify the whole fraction. And then C is something else totally different, isn't it? C is just evaluate. So pay super duper close attention to the words. The words will tell you what to do. Just by looking at the math, you really won't know what to do. Make sense? Okay. Any questions? Okay. You had enough time there, Sam?
Yeah.
Okay, cool.
I was just confused. I didn't know how to do it at first.
Okay, I saw you were writing. I didn't want to cut you off. Okay. Thanks for taking good notes. Okay. And then lastly, this one says evaluate. If you could describe what the word evaluate means, like what you're supposed to do, what does evaluate mean?
Solve.
Not solve. Definitely not.
Simplify.
Say again? No, definitely not isolate either. These are all good math words, and we do these things.
Reduce.
Oh, there it is. I heard it.
Plug in.
Plug in. Whoever said that? You say plug in? Yeah. So evaluate means plug in. You're just going to plug in some number for x and then follow order of operations. So here's what it would look like for this one. It'd be empty parentheses squared minus empty parentheses minus 6 over empty parentheses squared minus 3 times the empty parentheses. And then, of course, what goes in there for the x is minus 1, negative 1. So negative 1, negative 1, negative 1, negative 1. So then as I follow the order of operations, I'm going to handle my exponents first. What are these two right here, the negative 1 squared and the other negative 1 squared? Both of them are positive 1. That's right. So it's going to be positive 1. I'm going to go ahead and handle this right here as well. Minus 1 is really plus 1, minus 6. And then down here, like you said, 1. And then minus negative 3, if you want to do that over there. It's really plus 3. Oops. Okay, so then 1 plus 1 is 2. 2 minus 6 is negative 4. 1 plus 3 is 4. And then finally, I go ahead and do the division of the fraction. So, or I reduce it down to negative 1. Saw a lot of those as I was walking around. So I was hoping that was going to be the answer. You guys have any questions? So as far as the objectives for 7.1, I would say that if you did A, B, and C on this one well, like if you did those well, you didn't need any help, you got them all right or whatever, I'd say you're doing great. You're like on the road. This is like on the road to success. This is what we want. If there were some, mess ups, some errors, issues, whatever, obviously we're here to continue to work on that stuff. I'm here to take questions if there are any. You're all kind of looking at me like I feel pretty good, but I could be misreading you. Not everybody's like that, but most folks are. Give you a chance to say something? No? All right, fair enough. So what do you guys think of the video? Seemed like totally different, good, bad? I mean, I'm assuming you're going to vote for it, if it came to like math video Oscars. Yeah, okay, fine. I'll try to add in some real neat special effects and some drama. Manufacture some drama for you. If I could get you to cry during a math video, that would be something, wouldn't it? If you felt badly enough for the numbers or something, or you were happy enough to finish, you shed a tear or two, that would be incredible. I don't know. Do you think I could do that?
I think if someone was crying during a math video, it's because they're so confused.
No, I was hoping they'd be so happy because they just figured it out. They're like, it's been so terrible, but this video just made it so good. No? All right. So I guess I don't need to supply you all with Kleenex when you watch the video.
Probably.
All right. Fair enough. Okay. Hey, guys, listen up. We're going to do number 4 here in just a second. But I thought I would kind of piggyback a little bit off the video. Please don't write this down because this is not really part of number 4. I'm just going to do this off to the side. I want you guys to think of what we've done in these situations in the past. I hope this will connect really well with the video. If I showed you some fraction multiplication problem, maybe the instructions said to multiply, and it was something like, I don't know, how about 12 25ths times 15 144ths. Please pay attention. I think this will help you understand why we're about to do what we're going to do. You look at a fraction like that, a fraction multiplication like that, and isn't it true that if you were going to do this, couldn't you just multiply the numerators times each other? Yeah. And then multiply the denominators times each other? And that would end up giving you an answer? I mean, that's... Hold on. Yeah, that's a valid approach. But I think where you're going to find struggle here is the numbers are going to get really, really huge. It's going to be hard to see what Haley just said, the reducing thing. And so what I think is it's easier to reduce before you do the multiplying, right? Kind of that cross-reducing. You know what I'm talking about? So do some canceling and reducing before you even multiply, because otherwise the numbers get really huge, kind of confusing. It's easier to do it when the numbers are small rather than large. So what if we did something like this? What if we looked at this and said, 12 is kind of one of the smaller numbers up there, but 25 is 5 times 5. What if I wrote it like that? And what if instead of 15, I wrote 3 times 5, right? I'm going to factor these a little bit. 144 is the biggest number up there. Anybody know kind of a special factoring for 144?
12.
It's 12 times 12. Significant because of that 12 up there. So notice what I've done here. All I've done is I've taken 3 of them. I could have factored the 12 as well, but I've taken 3 of the components here of numerators and denominators, and I've just factored them. So do you see now how I could maybe do some canceling? Couldn't I cancel this 12 with that 12? I'm trying to reduce first. This will make it easier. Let me finish my process real quick. Whenever the numerator is empty, what do you put?
0.
A 1. Numerator empty means 1. Right, because 12 over 12, I know, 12 over 12 is 1. And you guys see how this 5 would cancel with that 5? So it'd be 5 over 5 is just a 1. So then what you could do, now that you've done a bunch of canceling, couldn't you now just multiply the numerators together? Now it's just 1 times 3, isn't it? Those are the only things that didn't cancel out. And then down below, 5 times 12 is 60. You know, and you look at this and you realize, you know what? We didn't actually cancel everything out. Right? Because doesn't 3 go into 60?
Yeah.
How many times?
20.
Yeah, so this is actually 1/20th. But do you see how the fact that we factored and canceled before we multiplied made it finish a lot easier? And so that's going to be kind of our goal here. I imagine you can see it like with number 4. If you look at number 4 and you think, if I multiply those numerators together, isn't it going to be a binomial times a trinomial? Not impossible, but it's going to make a big mess. Same thing in the denominator. And it's going to be borderline impossible for you guys to do any reducing. I hope you're listening. So our strategy is going to be what we just did. We're going to try to factor. I mean, can I just be like really honest? Isn't the first step for this whole chapter factor everything first? Like that's always going to be the first step. So we're going to factor a bunch of stuff first, look for some cancellations. Therefore, the finish should be quite a bit easier. So we'll do that here in a second after Grace's question.
Yeah, I'm confused. Really confused. I don't understand where this started from.
You don't understand what?
Like, I don't know what,
This,
where all these
Grace,
things came from.
Grace, this was just a little example from your 5th grade past to help you identify with what we're about to do. This question right here does not have any direct relationship with this other than that they're both fractions being multiplied together.
Okay.
Okay? So it was just designed to help you get some momentum from the video's connection to what we're going to do right now.
Sorry.
It's okay. I tried to make that clear. I said I'm just going to make something up off to the side, and yeah, it's okay though. So, as I said, the first step, always factor everything first. So let's go through this one together here, and this is somewhat like the video. This one's a little more complicated. So let's go just step by step right here. Take a look at that upper left numerator. Factoring wise, we always want to ask ourselves if there's a GCF. Do you guys see a GCF in that one?
Yes.
8 and an x, right? Do you see how both terms in that upper left have an 8 and an x? So I'm going to come down here and I'm going to say that that is going to become 8x. And then what would the leftovers have to be for that one? X minus 1. Remember, whenever you factor out the whole term, there's a 1 left over. So this would be x minus 1. There's nothing else we can factor there. Let's see. I'm going to do this other one down here just to try to be efficient. Do you guys see now the one that I've highlighted in red, the lower right one?
Yes.
Is there a GCF there?
Yes.
Yep. What is the GCF? It's x. That's right. And if you factor out that x, what's left over?
X minus 1.
X minus 1. Okay, that's cool.
What?
So I handled both of the pieces that had GCFs, right? Remember, the whole goal here at the start is factor everything. Try to factor everything. So then when you look at the other two, the ones we haven't dealt with, that one and that one, those are not binomials. Do either of those have a GCF? I don't think either of them has a GCF. So what we're going to have to do is use that trinomial factoring, the magic x split the b thing. So let me leave that up to you guys for a few minutes here. See if you can factor both of those. And I would bet that once you factor both of those, all of the cancelings and stuff that we'll be able to do will become even more clear. They'll become a little more obvious. So we're working on factoring what I've highlighted in red, and then you can do that off to the side if you want, and then we'll put them back in where they go, and then we'll do our simplifying and multiplying. These two, let's check your factoring here. This lower left one should factor as x plus 8 times x minus 7. Yes? Yes. Good. Look at that for a second. I've only done that one. I still got to do the upper right one. Are you guys okay with that? Do you have any questions on how that factored? Okay. And let's see here. The other one is going to be a 3x and an x. And it would be, what, minus 7 right there and minus 1 right there. So again, please take a minute and look at what you have on your paper. look what I have up there, and decide if you need to ask any questions. I didn't show a whole lot of work there, but I'd be happy to show work as needed. Grace?
Does it matter what order? Because like for the first one, on the denominator, I said x minus 7 and then x plus 8.
It doesn't, because multiplication is commutative, so you can flip the order and it's okay. Yep. Other questions on either of those? Again, please look at what you have on your paper. It could be we match exactly, and if so, that's great. But if there's any question as to what I got up there, how I got it, now's an opportunity for you to say something. Because I'm about to make a bunch of things go away, right? About to do some canceling. Okay, well then let's take a look at how this is going to cancel. I'm going to do all that canceling beforehand like we did with that other example. So I'm going to have the x minus 1s cancel out. I'm going to have the x minus 7s cancel out. And there's one more canceling that's not totally obvious, but it's there. What is it? The x, yeah. So this x right here and this x right here, those are both factors, right? Because they're whole factors, x times this, 8 times x times this. So those cancel as well. There we go, and there we go. Leaving me in the numerator with an 8 over x plus 8 times, gosh, that's just 3x minus 1 over 1, isn't it? Okay, so then the final step here would be to remember that the way that you multiply fractions is to multiply the numerators together and then multiply the denominators together. I think I'd probably just use a distributive property. So I'd say 8 times 3x minus 1. Yeah, you don't even have to do this. If you just want to write it like this, I'm fine with that. And then, of course, x plus 8 times 1 is just x plus 8. If you left it like that, I've got no problem at all. If you want to distribute the 8, that's fine too. But if you left it like that, that might even be better. You can clearly see there's nothing else left to cancel. So, okay. So again, we did all that canceling. We did the multiplying and stuff. Question? Yeah?
Can you simplify when you have 24x minus 8 and then over x plus 8?
So if we did distribute,
Yeah.
so let's look at that. So 24x minus 8 is the result of the distributive property. Still have x plus 8 there. So what are you proposing for a cancellation?
Yeah, would you go any further or would you leave it at that?
Well, you either can or can't, right? There's not a question of like, well, Alex went further and Alec didn't, and Sam did this and Cole did that and blah, blah, blah. What are you proposing?
Well, I don't know. I just thought, couldn't you
Isn't it tempting to do this? Is that what you're getting at?
Kind of like distribute the 24 x and then get 8.
What do you mean distribute the...
Find a common factor between the two.
Isn't the common factor 8?
Oh yeah, I don't know.
So you'd just be undoing what you just did. So the short answer to your question is we're done. There's no more simplifying you can do. But people will be tempted all the time to cancel the 8s out or maybe the x's. Remember, you can only cancel the entire factor or not, or none of it. You can't cancel part of a multiplication problem. Okay. Let me close with this real quick. Let me just show you what we'll pick up with tomorrow, and then we'll get out of here. So we're going to be doing some division. We just have a couple of examples of division that we're going to do. I just wanted to point out to you here in the end, you're going to find that division is almost exactly like multiplication. Let me explain why I would say that. If you look at number 5, you can see that it's 9x over 35y, but it's divided now instead of times. Whenever you've got a fraction divided by a fraction, what's that little phrase you learned? Copy dot flop. So what I would do for a first step here is I would go copy, and then I'd change the multiplication to, or the division to multiplication, and then I would flop this one right here. And then I think if you look at that, don't you realize that that's the exact same thing as what we've been doing with these multiplication problems? And so we'll investigate that a little bit further tomorrow. So thanks for your hard work. Look forward to seeing you then.
Hey, Clay, you should have said that.